It's no secret that Chandrayaan-3 has already achieved monumental success, becoming the first mission to reach the lunar South Pole and unearthing lunar secrets, including the discovery of sulfur and other elements. However, the path to this triumph has not only been marked by successes but also huge setbacks in the past. Let's delve into the remarkable journey of the Chandrayaan missions, from their struggling early days to the recent triumphs, showcasing how persistence and innovation have propelled India's lunar ambitions to new heights. It all started with India's first space mission, Chandrayaan-1. Chandrayaan-1 was India's maiden lunar mission, a monumental endeavor that left an indelible mark on space exploration. Launched on October 22, 2008, it represented a milestone in India's scientific and technological capabilities. With a budget of 386 crore, which is about $88.73 million, Chandrayaan-1 aimed to unravel the mysteries of the moon.
Pictures from India's first lunar mission, Chandrayaan-1. The spacecraft has captured the shadow of the moon.
The mission's scientific objectives were ambitious, aiming to explore the lunar surface and to study the possibility of water ice in the polar regions. It also sought to study the moon's surface, topography, mineral composition, and exosphere. Key instruments like the terrain mapping camera and the moon impact probe were employed for these tasks, which are just fancy terms for instruments that are needed to create detailed 3D maps of the lunar surface. But perhaps its most groundbreaking discovery was related to lunar water. Chandrayaan-1 made a significant contribution to our understanding of the moon by discovering lunar water. The Moon Impact Probe discovered water molecules on the moon's surface. This discovery was groundbreaking because it suggested the presence of water and the potential for water ice in the moon's polar regions. This finding has important implications for future lunar exploration and the possibility of sustaining future lunar missions. Unfortunately, Chandrayaan-1's mission was prematurely terminated on August 29, 2009, after just 312 days in lunar orbit. The spacecraft lost communication with ground control, making it impossible to continue its mission. Before its termination, Chandrayaan-1 had successfully transmitted a wealth of valuable data, including high-resolution images of the lunar surface, mineral composition data, and the discovery of water molecules. These findings significantly contributed to our understanding of the moon. Chandrayaan-1 was India's first lunar mission, and although communication was unexpectedly lost, the data was preserved, and most important of all, presence of water on the moon had been detected. So, despite its premature termination, we can still conclude that Chandrayaan-1's mission was a success. The mission not only showcased India's technological prowess, but also expanded our understanding of the moon. Its discovery of water molecules on the lunar surface shattered previous assumptions and ignited a new era of lunar exploration. But not every Chandrayaan mission ended on such a good note. Chandrayaan-2, while ambitious and filled with promise, encountered its share of setbacks and ultimately met a tragic fate. To understand the full story, let's start at the beginning of Chandrayaan-2. Chandrayaan-2, India's second lunar exploration mission, launched on July 22, 2019.
Chandrayaan-2, it's a lunar lander. It's due to blast off in a few minutes' time at 2:43.
At a cost of approximately 978 crore or $142 million, making it India's largest and most expensive space mission yet. It aimed to expand our lunar understanding with a multifaceted approach, and with this mission, India attempted to be the first country to land on the lunar South Pole. The orbiter played a crucial role, tasked with mapping the lunar surface, studying the moon's exosphere, and analyzing the distribution of elements and minerals. Advanced instruments like the Terrain Mapping Camera 2, Solar X-ray Monitor, and dual-frequency synthetic aperture radar were used to facilitate comprehensive lunar mapping and scientific analysis along the way. However, the real challenge was landing on the south pole of the moon. This is how the dynamic duo lander Vikram and rover Pragyan were born during this mission, aiming to explore the lunar South Pole surface. They were created to conduct experiments and to analyze the terrain, minerals and topography on this unknown side of the moon. Vikram carried instruments such as the seismometer, thermal probe and Langmuir probe, while Pragyan was equipped with tools like the alpha particle X-ray spectrometer and laser-induced breakdown spectroscope. The most nail-biting moment of Chandrayaan-3 was the landing attempt. Vikram set its sights on the Moon's south polar region on September 6, 2019. However, during the descent phase, communication with Vikram was lost.
Subsequently, the communications from the lander to ground station was lost,
resulting in an unsuccessful landing. Consequently, Pragyan remained immobile, unable to undertake its planned surface operations. Luckily, among these challenges, the orbiter emerged as a beacon of success. It flawlessly entered lunar orbit and continues to orbit the Moon, diligently collecting data on lunar surface conditions and water distribution. In fact, the orbiter component is still in the lunar orbit to this day and is helped to ensure the success of Chandrayaan-3. How, you may ask? Well, it had already played an important role in identifying a relatively safe landing spot for Chandrayaan-3, ensuring its success. Chandrayaan-2 marked a significant milestone in India's lunar exploration program, exemplifying the nation's capabilities in lunar science and technology. Unfortunately, due to the lander's unsuccessful landing, the mission is marked as a failure since the primary objective was to explore the south pole of the Moon. However, the orbiter's enduring success remains a testament, and the lessons learned from this setback were essential in the growth and success of the next mission, which finally brings us to Chandrayaan-3. Chandrayaan-3 is an unmanned lunar lander mission by the Indian Space Research Organization and was successfully launched on July 14, 2023, with a budget of only 6.15 billion rupees, approximately equivalent to $75 million. This mission is significantly more cost-effective than Chandrayaan-2. The mission includes a new lander and utilizes the Chandrayaan-2 orbiter already in lunar orbit for communication. The lander Vikram and the rover Pragyan were born once again. Chandrayaan-3 also had the same mission objective as Chandrayaan-2 in 2019, which was to attempt to be the first country to land on the lunar south pole and to collect lunar soil samples for chemical analysis. On August 23, 2023, the same nail-biting moment happened for Chandrayaan-3 on its landing attempt. The tension was even higher because of the failed landing of Chandrayaan-2 in 2019. Luckily, Chandrayaan-3 managed to successfully land at the lunar south pole on August 23, 2023.
आप अपनी स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल
marking its day in India's history forever. The entire mission is planned to last for 14 days. The lunar south pole is of particular interest due to its potential for future projects. It has craters with permanently sunlit edges, making it suitable for solar panels. Additionally, the mission of Chandrayaan-1 proved the presence of ice in these craters and could be a valuable resource for water and oxygen in the future for a potential moon-based construction. The successful landing took place near the lunar crater called Manzinus U, which was discovered by the orbiter from Chandrayaan-2's mission. This achievement made India the fourth country after the Soviet Union, the United States and China to achieve a soft moon landing and the first to do so in the lunar South Pole region. The spacecraft will remain on the Moon after the mission. On August 24, 2023, the rover Pragyan made its first drive on the lunar surface, moving at a slow pace of 10 centimeters per second to prevent damage. It successfully detected traces of sulfur, aluminum, iron, titanium and oxygen on the lunar surface near the South Pole. Yet again, an amazing discovery. But that's not all of it. As the mission unfolds, Chandrayaan-3 still has a lot to discover. Its exploration of the lunar South Pole, with its potential for solar energy and water resources, could hold the key to future lunar endeavors, including the possibility of establishing a lunar base. Chandrayaan-3's triumph echoes the spirit of Chandrayaan-1's early successes and Chandrayaan-2's valuable lessons. It's a story of resilience, learning from setbacks, and pushing the boundaries of space technology. This mission not only achieved the historic feat of a successful soft landing at the lunar South Pole, but it also added another layer to India's legacy in space exploration. In the coming days, we can expect more exciting discoveries and scientific findings as Chandrayaan-3 continues to explore and analyze the lunar surface. Like and subscribe if you found this video useful, and we'll see you back in the next one.